Hello and welcome to another SOLIDWORKS tutorial video. In this tutorial we're going to be using the piston that we modelled in the previous tutorial, as well as a gudgeon pin, connecting rod and some gudgeon pin retaining clips to create an assembly. I'm going to be modelling the connecting rod, gudgeon pin and clips from scratch. I'm going to speed it up this time, but wherever I do something new I'm going to slow the video down and talk you through it. So I'm going to start off by modelling the con rod. So if you hover over a line, you can see this sort of yellow square appears. That's the midpoint of the line. So if I was to do it here, you can see there it is, and here there it is. So I'm going to now cut out sort of the holes where the threads would be to hold the bottom cap and the sort of upper con rod together. So I'm going to do that as half a hole. So the final part now is to split sort of this bearing cap here, to split the connecting rod into two, so we've got the bearing cap and the actual rod itself. So I'm going to do that by inserting a point. I can do it on the center of this face. There we go. Click OK. And then I'm going to put a plane. So it goes through the point 1, and I want it to be, if I use the front plane, it'll be parallel to the front plane. There we go. So we've got a plane now that goes perfectly through the center of that circle. I can then use that plane to split this. If I type in the commands split, it's asking me what the trim tool is, so I want this plane to be the trim tool. If I then cut the part, it gives me two parts, the cap and the rod. So I don't want to consume the cut bodies. If I untick that and then click OK, we've then got two parts. If you look in solid bodies, you've got the cap and the rod. I'll hide the point in the plane. So it's just worth pointing out that the con rod that I've just modelled is not identical to this one. I've simplified this massively just to make it easier for the tutorial. So the next part that I need to make now is the gudgeon pin, which is quite an easy part. So the final part that we need to make is these little gudgeon pin retaining clips. We only need to make one, even though there's two, because we can duplicate it in the assembly. I'm going to use the sweat boss feature for this one, so I'll talk you through how to make these little clips. So for the retaining clip, we're going to use the sweat boss base feature. This requires a path and a profile. So I'm going to first off start by drawing the path. If I create a sketch on the top plane, I'm then going to use the center point arc to draw this shape. So we've got sort of 3/4 of a circle there. I'm going to then put the horizontal line in. This is not fully defined, so if I constrain that point there with the origin and put a vertical constraint on that, that'll constrain that. So I'm now going to create some variables to help me dimension this. So the first variable I'm going to have is going to be the piston clip groove ID, which is the inner diameter of the groove that holds the retaining clip. That was 20 millimeters. The second variable is going to be the clip thickness, which is going to be set at 1 millimeters. And then the final variable is going to be the path diameter, which is going to be the piston clip groove ID minus the clip thickness. Don't need two equal signs. Click OK. So I can now, if I go back into the sketch, if I now add a dimension, because this is a radius, I need to half the diameter. So if I go on path diameter, select it, and divide it by 2 to get it into a radius. Click OK. That's now fully defined. The last little feature I want to put in is a fillet between this line and this line. If I put a fillet in there of 2 millimeters. So that's the path for the sweat boss. We now need to sort of determine the profile. So if I exit that sketch, because I've done that from the origin, I know that if I sketch the profile starting from the origin, then it's going to be in the right place. So if I do a sketch, and I do it this time on the right plane, Control 8 to bring it to screen, and if I just draw a circle, starting at the origin, if I make the radius of that equals clip thickness divided by 2, click OK, and then exit the sketch, I've now got my path and my profile. So if I go features, sweat boss base, it wants me to determine here the profile, which is this circle here, and now it wants me to sort of select the path, so I can click this sketch here, and they can see that's exactly what we want it to look like. So if I just click OK, the final feature I'm going to add now is an axis line to make it easier in the assembly. So if I go on reference geometry, axis, I can create an axis from 2 planes. So if I go to the selections, drop down this tree here, and I want to use the front plane and the right plane. So you can see there's an axis line that's gone where those planes meet. So if I just click OK, I can now stretch that out in both directions just to make it a bit easier to see. So there we've got our retaining clip. If I just save that, the next step will be to assemble it all. So to create an assembly, File, New, Assembly, OK. And it should open this window here. So we need to now put some components into our assembly. So if we first put in the conrod, so if I click the conrod and then go into this area here, I can click anywhere to place this conrod. That will now be fixed. So I need to now right click and make that float so I can constrain that properly where I want it. So I can now move this anywhere. So if I insert a mate is sort of what constrains the parts within an assembly. So if I click mate, you then get a box where you can select the 2 things that you want to mate together. So I want to mate the origin of the conrod with the origin of the assembly. So if I click down on here, click the origin of this part and then click the origin of the assembly, you'll see there that the 2 origins are now coincident with one another. So that's the right mate that we want. So if I just click OK, so now I've got my first part in the assembly. I need to now add some more parts if I OK this and then click Insert Components. I can either open the documents from here or I can click Browse to select a document from anywhere else. So I'm going to click Browse and open up the piston. So once I click the piston, if I just click anywhere to drop it into the assembly, I'll then add some mates. So now I can move this piston sort of anywhere. So the first mate that I'm going to do is I'm going to mate the centre of the conrod small end with the gudgeon pin bore on the piston, and I'm going to make that a concentric mate. So that's concentric ticked. If I now click OK, you can see that I can move the piston. I can rotate it around the axis or I can translate it across the axis, but it's always going to be concentric with the conrod small end. So I need to constrain this piston so it can no longer translate. So there's two ways of doing that. I can either do it via the planes or I can insert a mate, an advanced mate. I'll use the advanced mate for this example. If I go to advanced mates and then click, if I untick the selection, if I click width, you get two boxes. So you click the sort of the symmetry lines of each of the components. If I, for the top box, if I click the inner flat face of the circlip groove on one side and the inner flat face of the circlip groove on the other side, that's okay for the first selection. And then the second selection for the conrod, I'm going to do the external face here on one side, so I get the right symmetry line on the other side. There we go. So that's now centralised the piston on the conrod. So if I click OK, so the only sort of ways that this can move now is it can rotate about the axis that we set, which is fine because that's what a piston does in operation anyway. We can set some limits on that, on the movement of that piston. I'll show you how to do that now. The mate selection, so if I go on the conrod, if you're unsure which sort of plane you want, instead of left clicking, if you right click, it sort of highlights it. So if I want to make the right plane of the conrod with the front plane of the piston. So initially that will put a coincident. Parallel would do the same thing, but for this, because I'm setting limits, I want to set the angles. So if I go into advanced mates instead of standard mates and click the angle, if I put an angle of 30 degrees, for example, and then this is the upper limit, and then this is the minimum value, the lower limit. If I put minus for that, and then if I click OK, we can now still move the piston, but it's got limits at either side, so it can only go between 30 degrees of the two planes, as you can see. I can't move that any further. If I go to the mates on this left hand side, where we've got this angle, if I just suppress that, I'll show you what we could have done before. We could have rotated the piston all the way around. So another feature in the assembly, when you're in the assembly window, is if you go to move component and then you click collision detection, you can then move the one component and it'll tell you when it collides with another. So you can see the conrod's highlighted blue where it's colliding. If I do the same on the other side, it'll highlight when it's colliding with something. That's a useful feature if you've got quite a complex assembly. So if I go back to standard drag, then I can spin it round. So if I just unsuppress that, then we've got it back to the angles where it can only move to the angle. So now we've got our piston and conrod, we need to put the gudgeon pin in. So if I go back to insert components, click gudgeon pin, click it once, and then click anywhere in the window to place it. I'll show the other method of putting that sort of halfway along the conrod this time. So if I put a mate on the outer diameter of the gudgeon pin and the gudgeon pin bore again on the piston, that'll make it concentric to the two. So if I click OK, I can now move this. Again, I can translate it along that axis and rotate it along that axis, but that's the only movement. So I need to now constrain this from translating across the axis. So to make this a bit easier, I am going to hide the piston. So in the left hand side, if I go to piston, right click, hide components, I've now only got the gudgeon pin and the connecting rod. So the way I modelled the gudgeon pin, I did it as a mid-plane extrude. So if I go on the gudgeon pin and click the front plane, you can see that it's symmetrical about the front plane. So if I mate the front plane of that with if I go on the conrod, there'll be a plane that I can mate that with. So if I think it's the top plane, yes. If I click the top plane, I can make those coincident, which means that the two planes are touching one another. So now we've got our gudgeon pin in place. The final thing that we need to do is to add these circlips, the retaining clips. So if I go in insert components again, click the retaining clip, but this time instead of clicking in the sort of the workspace, if I click the keep visible, I can click once and it'll still be there, so I can click again. There I've placed 2 of the circlips. If I click OK, what I'm going to do this time is unhide the piston and hide the gudgeon pin, because I'm sort of mating these with reference to the piston. So if I hide the gudgeon pin and unhide the piston, there you can see got the piston back. So the first thing I'm going to mate is I'm going to mate the gudgeon pin bar of the piston with the central axis that we put in, which is the reason why we put that axis in, to make life a bit easier. So if I select the axis within the circlip and then select the gudgeon pin bar, you can see that now they've gone concentric to one another. If I click OK, that can now either rotate or translate along that axis again. So we now want to mate that with the sort of groove that we cut out for it. And a way of doing that is to click the edge and make it tangent. So if I click the inner face of the retaining clip groove, it will then automatically put a tangency constraint. So if I flip the direction of that, it'll go the wrong way. If I flip it, then it'll be in the groove. You see, if I click OK, we've got our retaining clip within the groove. If I do the same for the other retaining clip, we will then have a finished assembly. So the final thing I need to do now is unhide the gudgeon pin. And there we've got it. We've got our piston, conrod, gudgeon pin and 2 retaining clips all in the right places. And I can now, the only motion that's allowed is for the piston to rotate in the way that it would within a cylinder. So that's it for this tutorial. As always, if you've got any questions, then drop me a message and I will get back to you as soon as I can. Thank you.